All right, guys, we are here for a factory tour at Warren Industries in Clackamas, Oregon. Now, this is the place where they make all their winches, they fab all their bumpers, tube work, all that jazz, and then there's a whole other facility where they do OEM parts as well.
That's correct. This facility is 200,000 square feet, and we're going to go inside today and meet the people that make these bumpers and winches and the rest of their gear. But 200,000 square feet of manufacturing facility. The place is huge, and it's going to be really exciting to see how they do this.
And they have over 500 employees. I mean, if you take a look down the row here, these are all employee vehicles. I mean, they're passionate about the sport, they're passionate about wheeling, they love what they do, and you will see how passionate they are about their jobs when we go in there. So.
They even brought in a fire truck for us to check out because they sell not only to municipalities but also the government, your military vehicles, make a lot of products, and well, it's going to be an interesting day.
And you're going to find out in just a minute, so come on with us.
All right, Jesse, this is going to be awesome. Hi, guys. How you doing?
Nice to meet you. I'm
Steve, Kent,
how are
nice
you?
to see you guys.
Welcome to Warren Industries.
Well, thanks. What do you got on plate for us today?
Come on back and we'll show you our entire manufacturing facility here in Oregon.
On our way out to the factory floor, I thought we'd stop by engineering here for a second. Just saw these parts laying around and a bunch of guys working in computerized modeling. But why don't you tell me how many engineers you have and what are they doing?
Overall, we have about 30 engineers. This division over here is the aftermarket division and also the severe duty and OEM division.
And that's where we're going to go watch them make parts right now?
Yes, sir.
Okay, so from designing it in here to making it out there, just checking it out.
Excellent. Thank you.
Now this is basically where it all starts, right? All the materials come in here, get dispersed down that way, and then they become product going that way.
That is correct. Right now we're standing in the steel bay, and so we have raw materials that come in here on a flatbed truck. You can see right here behind us, Glenn has got some ring gear material that's being lifted, and it's going to be taken down here, and the machining processes are going to start.
All right, so the material gets dropped off and comes into right here.
That's correct, yes. You can see we got raw material here. We've got a large chop saw that cuts off the ring gear material to length, and then it goes from here to our CNC machines that do multiple machining processes to end up with a finished good piece like this.
So it goes from that to there, all in this one little area.
That's right.
And then where?
And then it goes on to our broach. So the broach will cut the inside splines for our third stage gear.
The Broachzilla?
Yes, the Broachzilla.
Shall we go see the Broachzilla?
Let's go. It's right over here.
And this is Broachzilla. It's kind of a world famous machine. It's about 20 foot tall, and what they're going to do is force this tool, the broach, through the ring gear, and it's actually going to cut these teeth in there.
Okay, what's going on behind us here is in Broachzilla is we take a ring gear that's not machined, it goes through the pole broach, and it cuts the splines inside the ring gear like this here.
So progressively, so down here it's really, really smooth, and then up here the teeth are large. So that's
right.
That's the rumble.
That's right. That's the rumble as the pole broach is pulled through the ring gear.
And then the shavings come out there, and it's done.
The shavings come out here, as you can see. Yes. For our large frame winches up to the 18,000 pound, instead of using Broachzilla to cut the splines on the ID of the ring gears, we use a gear shaper here. In order for us to use a broach to cut the splines on a ring gear this diameter, the broach would have to go through the ceiling because it would need a lot longer tool. This is our Robo Drill. This here cuts the 10 holes in the ring gear that the Allen head cap screws will be used to go through to assemble the final gear housing. The Robo Drill has drill bits that actually have holes inside that the cutting oil goes through. We use about 600 psi of pressure for that cutting oil, so it cuts really, really fast.
Okay, Steve, so what do we have going on in this work cell here?
This is our large frame winch drum support casting cell. We have a raw drum support that's come in already powder coated, and it's going to go through multiple steps here where we do the machine work. We drill and tap holes, and then it'll be ready for production.
Okay, so this one guy is working on 3 machines. So the first machine he does
the ID of the casting here for the bearing and also the drum bushing.
Okay.
The second machine will drill and tap the holes.
All right.
And then the third machine does the final machine work for the motor itself.
Sparks. I see sparks.
A lot of sparks back there. This is our drum cell. This is where we're making the drums for our M8000, XD9000 type winches. We're going to take some raw material like this here This is just like what we saw come into the building right at the beginning.
Right.
And we're going to make drums just like you see right there with the wire rope spun on them.
And so it's an automatic welder.
This is an
right
automatic welder here. He loads up the drum tube and the drum flanges, hits the button, and it automatically welds the flanges to the drum. Sparks.
That's my favorite thing.
Okay.
You know I like welding, right?
You like welding?
Yeah,
I've
I love
seen you
welding.
weld before, yes. Over here we've got our drum spooling machine. So this automatically spools the wire rope onto the drum. You can see it's got a level wind device, so it spools it on evenly, and it also measures the length, so we have the precise length of wire rope.
All right, so what is this part right here?
That is the sun gear.
Or it's going to be a side
It's
gear.
going to be a sun gear.
Okay, so how does it go?
As it goes, we load the bars, the raw stock, into the machine. The machine has 6 spindles plus a drill. As it goes around and does its 6 spindles, it shapes, gets its final shape, and drills the holes in, drops out over here. And then when we're done here, we wash the part, take it over to the shapers shape it, we take it to heat treat, harden the steel up, and it's ready to go.
So maybe I should go talk to the shapers right now.
Get them in shape.
Thanks, Dad. 13, 14. So there's 14 of these machines, and 1 or 2 guys runs just to shape this into that.
That's right. We've got our gear shapers behind us. We have one attendant that runs all 14 gears. That's called efficiency. Just a bit of history. The story is these gear shapers came off of a World War II surplus machine ship, and these were all built back in the 40s.
All right, Lance, so this is another type of broaching machine. You want to explain to me how it works?
Okay, this is a pot broach. There's a ram here, and there's blades down here in this pot. And what it does, it starts out at a shallower depth of cut. These parts here, we feed them in through here. There's a shuttle that will shuttle it in. Once this is at the top, it'll shuttle it in. The ram comes down, and it actually just shoves it right down through those blades. So it comes out into the bottom. Then it'll come out over here on the conveyor and spit it out over here.
And then all those blades are tapered, just like a broaching machine that we were looking at, like
Yes.
Broachzilla.
Like Broachzilla, it starts out at a smaller cut,
Right.
tapers up. This one here basically tapers down through it to the bottom.
Perfect. So we've been out and we've been watching all these little parts. Now this is the part where the area where it starts actually coming together to make an assembly of a sort.
That's correct. This is one of our carrier assemblies for one of our planetary gear sets. So we're taking some of the gears that we were cutting over on the gear cutters, and we're going to make them into a planetary gear assembly like this here. So this is the first sub-assembly that we're putting together that'll make the final winch.
Now it's really cool to start seeing all of these parts finally coming together. What is the raw to the finished product right here?
This is one of our end housings or gear housings, and this cell here is going to do all the machine work on this. This is going to eventually go onto an M12 or M15 winch. So he's doing the ID machine work to install the ring gear and also install the clutch lever.
The clutch lever. So this is the magic moment. We've seen the raw material go into parts, into sub-assembly, and this is where it all comes together.
That's right. This is one of our large frame winch assembly areas. You can see back here the attendant's actually building an M12,000 winch. He's pulling the gear housings, the drum supports, and all the other parts that we'd seen, the gear carriers, and making a complete winch. So it's going to go from here over to testing, and then from testing into the box, and then off to the customer.
And out to you guys.
There we go. That's it.
So you're the last guy to actually see the winch before it gets packaged up and out to the customer.
Yeah, I box it and close it up when it's done, have everything in it, and then I ring the bell for the material handler to come get it.
So this could be your winch. You know what? Let's make this one a special winch. Can I help you box this one up?
Yeah.
All right. All right, so we've been checking out all the winches that we would use on our own recreational vehicles, but you guys also do little guys as well as the bigger guys, right?
That's right. We do ATV winches, plus this here. This is a motor sub-assembly for one of our severe duty 18 winches. This is an 18,000-pound winch component. These are put on the MRAP vehicles that are being used by the U.S. government and other governments throughout the world. These have 100% potted motor and control pack assemblies. We also have an OLI, which is an overload interrupt device to limit the pulling capacity for safety.
Now that the winches are all built, we got to have something to put them on. So we're on the fab side of everything, which is very similar to the other side where the raw materials come in and then they go through the whole fab process. So right now we're at sheets.
Yeah, we're here at the fabrication side of the business, starting with our flat sheet stock. Anything from 1/8 inch to 1/4 inch mild steel and aluminum. We're going to take it and process it from the raw state across the punch press through to the trump laser and then off into press brake.
Alright, so it goes from sheet to punch to laser to part.
Correct.
Now how long does that take?
This is going to take you about 3.5 minutes from raw sheet of steel through the punch, through the laser, and into the basket per part.
3.5 minutes?
Yeah.
Okay, but there's still more, obviously. It's got to turn into something.
From here, we'll take it over into our CNC press brake operations and then off into our welding.
Well, let's go.
Let's go.
All the parts have been completely lasered, and then they come over here to the brake.
Correct. So what we've got over here is all your left-hand brackets, your right-hand brackets, your upper parts, your lower parts, coming into one kit. And the press brake is getting set up to bend each and every one of those profiles.
Oh, see how the...
Relief cut.
Yeah.
So you can do an overbend on a 90.
That's how you do it. Now, the parts are bent, and they come over here.
Correct. We're over at our robotic welding center. What you're going to see here in front of you is two different setups. So we've got winch mounts, and we've got mounting brackets. And what they do is set up a bracket kit on one side and the winch mount on the other, and we'll proceed to see it rotate into position. It's going to cycle on us too. If you watch it a little bit longer, it'll cycle and you'll rotate the table out.
So we were just over at robotics, and I walked by, and I'm like, oh my gosh, there's a chick welding in there. What's your name?
I'm Brittany.
Brittany, how old are you?
I'm 23.
And how long have you been working here?
About a month.
About a month. How long have you been welding for?
A few years, since probably 4 years.
That's awesome. Now, what are you making right here?
Rock sliders.
Rock sliders. And
Yep.
these are your beads, and they're absolutely stunningly gorgeous. It looks like a robot did them.
Thanks.
Yeah. Dude, I love it. High five, sister, because I'm all about chicks welding and rocking out. It looks like there's robotic mandrel bending going on right here.
Exactly. We have CNC bending for all of our brush guards, draw tubes, bumper configurations, anything you need. We can bend from 1/4 inch up to 2.5 inch.
Do you do custom applications?
No, unfortunately we don't.
All right, now a lot of us know the benefits of powder coating, but this is the powder coating station, so tell us how the parts get from basically this to final product.
You bet. What we've got here is a fabricated bumper. It's all been ground, sanded, welded, bent, ready to go into paint. So on the left side over here, we're going to hang the part on the chain. It's going to come around through a wash system. It's going to go into a dry-off oven, into the powder, into the oven for cure, out of the cool-off line, and into the box.
Now, I see that they're actually hand spraying the powder.
Yeah, they apply the powder dependent on the size and the density of the part.
Okay. Now, how long do the parts actually ride on the chain for?
This is about a 2-hour process from hanging the part to taking it off and packaging.
And it's not like it's a whole bunch of the same parts, like, in a row. So is it the actual kit?
We'll have the whole entire kit. So all your left hand, right hand, upper, lower brackets, your cardboard, it'll all come in. They'll separate the parts that get painted from the parts that get packaged in the cardboard, and they'll pair up again at the end of the line.
Well, as you can see, we're inside of Warren's top secret testing lab, and I'm here with Darren, and he's going to tell us a little bit about what we're seeing.
Well, right now we're doing some catalog data on our new Olympus winch line, and this machine will test line speed, voltage, and what type of current we're seeing in the product.
So after the engineers design the product, they build it out on the shop floor, they bring it in here, and they prove can it do it or not.
Yeah, we'll look to see if anything's going wrong in the motor or the brakes, or if it's running too slow. You know, there might be some efficiency losses in the gear train.
Well, it's pretty cool. How much pressure is being applied to this right now? 20,000 pounds?
Right now we have 20,000 pounds on it, and we'll be doing a pull here in a second.
I don't even feel like I'm in danger.
You're not.
Okay. So literally right now this thing's pulling with 20,000 foot-pounds of force.
Yeah, it's pulling at 20,000 foot-pounds, and it's at about 6 feet per minute. And trying to see what I don't think we have our amps up, but I think it's only pulling about maybe 150 amps.
Definitely enough to get you unstuck. Well, I figured since they let us in the top secret test lab, I'd grab Scott, who is the test lab team leader, and why don't you tell us what this contraption's all about?
We do a variety of environmental testing. This one happens to be taking it down to -40, and we'll do different types of function tests and current draws on it. So you can go take a look at it.
So right now we're at -20 degrees, and what's inside the cooler?
This is one of our compressor winches.
Okay, well, let's open it up, take a look. So am I understanding this right? My Warn winch is going to work at -20 degrees if I happen to be like wheeling in the Arctic?
We test it down to that, yes.
Wow.
And there's other specs on depending on the severe duty or other applications.
-20 isn't severe duty?
That's
standard duty?
Standard duty.
Wow. Now I know you're not suggesting that people go out and use their winch underwater, but you're testing it underwater. What's up with that?
Well, depending on your application, we do have the proper seals in the winch to be able to run like a fording type application. But not every winch, like you said, will do that. It's more of our severe duty applications.
And so you actually seal this up, pressurize it, and that simulates a certain depth underwater that you tested at?
Most of them we put 5 to 7 psi on, so we simulate a meter's worth of submersion.
So it's like what, 3-point-something feet?
That's right.
All right, well, I guess they'll work 3-point-something feet underwater if you've got the right Warn winch.
Welcome to Pheasant Court. Pheasant Court's a facility of about 180,000 square feet. We produce the ATV winches as well as all the OEM hubs and aftermarket hubs.
All right, so basically we're on the beginning of the small winch assembly line?
Yes, that is correct. The small winch assemblies or winches are built into several different stages, and here we're looking at the gear train assembly. And each winch has basically 3 different planetary gear sets, and this is kind of where we do the assembly work here.
This is what you call the coupler machining center, right?
That is correct.
Now, this is like more of a machine process of the broaching process that we did in the bigger building, right?
Correct.
So, how does it go? The raw material goes in.
Right. On the CNCs, we have a couple of R-feed machines. We have a rack where the raw material goes into the machine. It basically does the OD ID on the blank.
Right.
The blank comes out onto the conveyor.
Yep.
And then it goes onto a main conveyor where all 3 machines, all the parts are funneled into our broaches. And we have an automated setup where we do a ID broach first, and then we do an OD broach, and then they wash the part, and then it goes on to a local vendor for heat treatment.
Basically, if you drive a Ford, the hubs are made here at Warn. Now, when you look at the hubs, normally you don't really think about how much goes into it. But if you take a look at all the parts that are manufactured to go into this one piece, there's a lot of parts.
There's a lot of parts and a lot of steps.
Yes.
To build this hub. And what we see here is 2 different versions of the hub for Ford. It's a manual version and an automan version. So push button 4-wheel drive, or else get in and manual lock the hubs.
Manual lock. If you have ever had a Dana 60, you have had these hubs. You've seen all the parts being assembled, and this is where the assembly line actually comes together to make your 35 spline hub right here.